Happy Sunday, everyone. Welcome in. We're going to be doing some factoring today. Thank you for the double taps. So we're going to be practicing factoring. So if you know anybody struggling with that, hey, Chastity. Hi, Karen. Welcome, you guys. Thank you for the double taps. Alrighty, so it says use the distributive property to factor each polynomial. Hey, Jazzy. Welcome back, Jazzy. Happy Sunday, you guys. Alrighty, so when we think about factoring, we're thinking about the greatest common factor, okay? So we're trying to decide what can we take out of 16 and 40. And both of these have 8. So we could take out an 8, okay? And then what we're asking ourselves is 8 times what can give us 16t? Well, 8 times 2t, because 8 times 2 is 16, and then bring the t with it, will give us minus 8 times what will give us 40y. Can I see your answers in the chat? 8 times what will give us 40y? Good still. 5. Sip said 5. Hey, Sip. 5y. Perfect. Bib said 5y. Yes. So it is 5y. And remember, whenever you factor, you should be able to distribute it back in to get back to your original answer to know if you did it right. And that would be our answer. Great, you guys. Hey, Bree. Welcome. Alrighty, so let's do number 2, okay? Now, I always say whenever we have a 0 and a 0, 10 goes into it. So we can take out a 10, and then we're asking ourselves 10 times what can give us 30v? Well, 3v plus 10 times what can give us 50x? 5x. And this is our answer. Alrighty, can I see number 3 in the chat? Can I see number 3 in the chat? What did you guys get for number 3? 2? Good. Okay, Monique said 2. Bib said 2k, parenthesis k plus 2, 2k. Wonderful. So 2 is the number that's the greatest common factor. We also have a k because both terms have k in common. So we could take out 1k because they both have a k. So now we ask ourselves 2k times what can give us 2k squared? Well, we already have the 2 and we already have 1k, so we just need one more k in order to make it a k squared, okay? Plus, good, I see that plus 2, okay? I see plus 4. 2 times what can give us 4? Well, 2 times 2 can give us 4. And then remember we have 2k times 4 gives us 4k. So this is our answer. Great, you guys. Thank you for the double taps. Can everybody double tap their screen for me? Can we get to 5K taps? And happy Sunday. I hope everybody's been enjoying their weekend. Alrighty, let's do number 4. Okay. Can you guys put in the chat, what is the greatest common factor? Thank you for the share. Tia, thank you. Thank you for all the follows. Thank you for the double taps. I see them coming in, you guys. 5Z, 5Z, 5C. Yes, let's go, Cole. Marlo, yes. So we have 5 and both terms have a Z. So it's going to be 5Z. Now we're asking ourselves 5Z times what can give us 5Z squared? We already have a 5. We already have one Z. So we need another Z. Good. Jit said, hey, welcome back, Jit. Said Z plus 5 times 2 gives us 10. So then we have 5Z times 2 gives us 10Z. And yes, Jit was right on. Tia, just send this to my freshman daughter since her Little, but won't stay off. Yes, send it to her. If she on social media, send it to me, okay? Yeah, this is Algebra 1. Freshmen should be, I think they're in exponentials or in polynomials. They should just be barely getting it to it. I think they're at. I think this is, some people are not here yet. Here for my freshman grandson. Oh, wonderful, Marlo. All right, so Sydney said factor out 2a. Ooh, Sydney, okay. Can we factor out more, though? We have a 2. They all have an a. What else can we add to it? Good. Bibby said 2ab. 2ab. Yes, because they all share a b. Okay. So now we're going to put a big parenthesis. Okay. We'll just start with the open. Then you have to ask yourself, 2ab times what can give us 4a squared b squared? Well, 2 times 2 takes care of the 4. A times, we have 1a. We need 2 of them. So we have to add another a. We have 2 b's. We only have 1 outside. So we need another b. 2ab. Yes, Chastity. Good. Okay. So now, let's go to the next term. What's going to go here? What do we put here? Vivi, I see you. Jazzy, yes, A. Good, you guys. 2, we already have a 2. We have an a squared here. We have a 1a on the outside, so we just need an a, and we have 1b. So it's going to be 2ab plus a minus 2 times blank gives us 10. Well, 2 times 5 does. We already have a 1a. And we have 1b, but we need b squared. So we just put b here. And this is our beautiful answer. Oh, yes. Thank you so much, you guys. We're at 5K likes. Thank you, Sings, for reminding me. Wonderful. Thank you. Thank you. Awesome, you guys. Thank you so much for the double taps. I appreciate it. All right. Okay, so now we're going to go into factoring polynomials, okay? And these are called, this is what we're going to do. We're going to do factor by grouping. It's a strategy that you use when you have 4 terms, okay? So what you're looking at is your first 2 pair only. So we look here and we say, what do these 2 things, what does that group have in common? Thank you, Carl. What do those 2 things have in common? Well, the first 2 have an a in common. So we can take out an a. Okay. Then we have parenthesis. And then we ask ourselves, what times what gives us a squared? Well, we have 1a, we need another a. And then what times what gives us negative 4a? Well, a negative 4. So we just look at only the first 2. We say they only had a in common, and then we do our distributive property to see if we can get back to this. Then we go to the next pair, okay? We go to the next pair, and we ask ourselves, what can we take out of these 2 terms? Can somebody put it in the chat for us? What can we take out of these 2 terms? What do they have in common? Thank you for all the follows. Oh my goodness, we're at 1.k. And we're at 7.5K likes. Happy Sunday, every morning. Happy Sunday. We're at 666. Good. Now, let me explain something. Whenever this leads with a negative, we want to take out a negative 6. Okay? I'm going to explain why. So, a negative 6 times what can, well, actually, no. We're going to take out a positive 6. We're going to take out a positive 6. 6 times what gives us negative 24? Well, a negative 4 will. 6 times what can give us 6a? Well, we need a plus a. 6 times a gets us 6a. Now, the debate comes in like, Oh no. Are these the same? Can I see a yes or a no in the chat? Are these the exact same parenthesis? Yes, yes, no, 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 yes. Oh, see, this is the great conversations that we have to debate. Now, we can switch these. Okay? If I switch the order of these, what I'm going to get is I'm going to put a positive A and then I'm going to put the -4. If I switch these are the same. So yes, because these are equal, they both have the same operation that's attached to them. Like here's a -4, here's a -4. Here's a positive A, here's a positive A. So don't let the difference, like how you order, how you write them, confuse you. Just switch them. Thank you, user, so much for the rose. Thank you, thank you. So now we're going to drop down this +6. And we're going to drop down this first part. A parenthesis A -4. Thank you, Courtney, for the roses. All right, now that we have these the same, right? These are the exact same. Now we can say, since these are the same, we can take our outers here, okay? The outers are what we factored out, and those go into a parenthesis together. So we put A +6. And since these are the exact same, they come down as 1, A -4. Thank you, Dia, for the hearts. Thank you so much. Wow, we're at 10K likes. Let's go. Thank you. For everybody that's double tapping, thank you for all the follows. Any questions on this? Any questions? Do you take the difference of, let me see, what was that question? Somebody had a question. I was never good at math in high school. Why did you take out the 6? We took out the 6 because both of these numbers can be divided by 6. Thank you, Fancy, so much. Thank you. So that's why we took out the 6. You're taking out what they both have in common. It's called the greatest common factor. So let's go here, okay? Factor by grouping. So we're only going to focus on these first two terms, okay? What do these both have in common? They both have in common an H. So I can pull out the H. And then I ask myself, H times what gives me HJ? Well, I have a J. And then H times what gives me -2H? I have a -2. Okay. Now, let's look here. What do these two have in common? Can I see it in the chat? What do these two share? Sydney said 5 + 5. Great. Yes. So we have a +5. We put our parenthesis, and then we say 5 times what gives us 5J? Well, 5, we need a J. And then 5 times what gives us -10? Well, a -2. As soon as you see that these binomials are the same, we know we did it correctly. Then we're going to take our outers, put them together, 5 H + 5, and then we're going to drop down one of our same parentheses. And this is our beautiful factoring. Good, Michelle. Yes. Wonderful. All right. Let's go to the next. You guys tell me. I want to see it in the chat. Oh, let me see. I'm never going to understand this. Yes, you will understand it. I'm telling you, you just got to, it's a lot of different level steps to it, right? First, you're looking at the greatest common factor, which trips up a lot of people. You learn that in middle school, and it's like, it's basically saying what number can go into both 3 and 21. What's the smallest number? Then you look at what's the smallest letter that they both share. So what happens to the square? This is not a square. Since they are the same, they come down as 1. Good. Riley said 3D. Stephanie said 3D. Beautiful, you guys. Yes. So the GCF is a 3D. Okay. Now we have a parenthesis. Now this is the part. Bibby, I see you. Bibby said this part is going to be t minus 7. Well, if you can't look at it as 3D times t gives you 3dt, do this. Put your GCF underneath it. Divide by 3D. 3 divided by 3 cancels. D divided by D cancels. So we're left with the t here. That's why we have 1t. Minus 21 divided by 3 gives us 7. And d over d cancels. So that's why we have t minus 7 in the parenthesis. Okay. Now, you see how we have a minus 5 here? Okay, this is what I was talking about. Here, I was going to say, oh, we're going to take out the sign that's attached. But you really take out the sign that's attached to the variable. So what do I mean by that? Let me explain to you what I mean by that. Since we know 5 goes into 35 and 5, right? 5 can be divided into 35 and 5. But we're going to take the sign that's attached to the 5 and we're going to put a negative 5. Now, let me explain why it's important to do that, because I see some people would have just put 5. But remember, we want these two to match. So if I divide this by negative 5 and I divide this by negative 5, 35 divided by a negative 5 gets us negative 7. Okay. Negative 5 divided by negative 5 cancels and goes to a plus t. Now we have the great debate again. I want to see this in the comments. Are these the same? Yes or no? Are these the same? Yes, negative times a negative is always a positive. Yes, 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 yes. Good. Somebody said, I don't know. Well, and thank you for your honesty. Thank you, Selfless, for the roses. Thank you. Some people don't see it as being the same. So switch it. How we switch this is we say T. Thank you, Ethan, for the rose. This is a positive T, so we switch it here. And this is a negative 7, so we can switch the negative 7 here. Now you see T minus 7, T minus 7. They're the same. So since they are the same, we know we factored correctly. Because when you do factor by grouping, these always must be the same. They always must match up. Thank you, Brian. Thank you, Riri, for the roses. So now we drop our outers. 3D minus 5 times, and we drop one of them down, T minus 7. And this is our beautiful answer. Okay. Thank you, Riri, for the roses. Okay, good. Okay, so will the parentheses always match? Okay, so we had a question in the chat. It says, will the parentheses always match? And what do you do if they don't? And how do you write the solution? Great question. If you're doing factor by grouping, they will always match. How you know you did something wrong or you didn't factor out enough is because they won't come out the same. Then you have to go back and look to see if you didn't get the greatest common factor, if you didn't pull out enough. Because when you do factor by grouping, they always have to match in order to come down as 1. Great question. And then if they don't match, it might not be factorable. Okay, you actually might not be able to factor it. Thank you for being here teaching us. Oh, you're so welcome. What does polynomial mean? Great question. Polynomial means letters and numbers, or just letters added and subtracted together. And it's 4 or more. Like this is a binomial. So it's 2 terms. This is a polynomial because it's bigger than 3 terms. So 1, 2, 3, 4. This is a polynomial. If it was only 3, it would be a trinomial, and so on. Okay, great question. Okay, so number one, what can we factor out? What can we pull out of this? You're so welcome. 4R. Beautiful. Okay, so we're going to pull out 4R. Well, if we pull out 4R, remember we're asking ourselves 4R times what can give us 8R squared? If you can't see that, put it underneath it. 8 divided by 4 is 2. And R squared divided by R, remember the rule is when you divide variables, you subtract their exponents. So this will just be R because we would do 2 minus 1, which just leave us with 1R. Good. Alex, I see that. Ethan, 2R plus 3. Beautiful, you guys. Plus 4. So if we do this, 12 divided by 4 is 3. These R's cancel. And this right here, baby, is our beautiful math. How did you get the 4R? That's a great question. How we got the 4R's, you can look at it as what times what gets you 8? Well, 2 times 4 gets you 8. And what times what gets you 12? 3 times 4. So both numbers had 4 in common. Both of the variables both had R's in common. So that's why we could take out a 4R. I hope that makes sense. Any other great questions? Thank you for the double taps, everyone. Thank you so much for the rose. It's the GCF. Yes. Okay, so somebody said, how do you know when to square the answer or circle the answer? Oh, that you can circle it, you can square it. It's whatever, however, just know that's your answer. We know that this is our answer because we have nothing else to take out. 2 and 3 don't have anything in common. So that's how we know when we're stopping. Okay, so let's look at number 2. Okay, we have 4 terms. So we know we're going to our factor by grouping. We're going to look here at the first 2. Okay, so what do we take out? What do we take out of these first 2? V. I see those V's coming in. Wonderful. V. Yes. So we have a V. We put a parenthesis. Okay. So if we divide this by V and we divide this by V, these V's cancel out. We're left with 1P plus these V's cancel out and we're left with a 12. Okay. Good. P plus 12. I see those P plus 12s coming in. Good, you guys. All right. Here we have, what can we take out of both of these? 8. Ethan said 8. Zion said 8. Good, you guys. So we have a plus 8. Now, if we divide this by 8, we're left with just a P plus, we're going to take out our calculator because I don't know that off the top of my head. Does anybody? Ooh, P plus 96. No, if we divide this by 8, we have to divide this one by 8. Good, so you guys are saying 12. I'm seeing 12s coming in, so we're going to take you guys. Okay, anybody disagree with this? Why do you leave the 8? We leave out the 8 because we're trying to pull something out of both of these that they have in common. And so 8 times 12 gets us 96. And then what times what gets us 8? 8 and 1. So they both numbers share an 8. That's why we're able to pull it out. Okay, great question. So now let's look here. Both of these have the same. That's what we wanted, right? And since both of these are the same, we know we're on the right track. We write our outers, V plus 8 on the outside. And then we drop down one of our same parentheses, p plus 12. And this is our answer. Thank you so much, Felicia, for the heart me. Thank you, thank you. Okay, so why don't you make, okay, let me see. There was a question. We said, why don't you make the greatest common factor 1 for the whole equation? We don't want to make it 1 for the whole equation, because if we make it 1, 1 goes into everything. And so then we wouldn't be able to factor, because if we just put 1, then we're not pulling out the greatest common factor. See, it's called the greatest. 1 is not the greatest. So V is the greatest common factor. Here, 8 is the greatest common factor, because you always want to pull out the GCF, okay? So we could pull out smaller numbers, but then that we'll still be having to pull out more in the long run. Okay, so I hope that makes sense. Isn't it the same on both sides? Oh, thank you so much, Heart, for the first gift. Thank you, thank you. Okay, so it says, Unknown says, isn't it the same on both sides when you take out the number or letter? Yes, they both have to have it both in common. So not the same sides. You only look at the first two and you only look at the last two to see what they both have in common. See, because we can't look at the whole entire thing, because 25 and 2 have nothing in common. So that's why you only look at the first two and the last two. Okay, great question. Good. So I see those 5Bs coming in. Yes, Jazzy. Yes. So 5B, put the parenthesis. All right. Can you guys write what's going to go in the parenthesis? Thank you, Michelle, for the rose. So we have a R minus 5. Good. Okay. R minus 5. R minus 5. Perfect. Good. And then I saw some people already go to here. So they said they're going to pull out a 2. So we put out plus 2. And then 2 times what gives us 2R? Well, R. 2 times what gives us negative 10? Negative 5. Beautiful, you guys. These are the same. We know we did it correctly. So we're going to do 5B plus 2. Bring down one of your R minus 5. And that is our answer. I'm struggling with factoring the most in algebra. Yeah, factoring is like, it was because it like incorporates so many different skills. Like, first you have to understand what the GCF is, right? If you don't have that down, then it becomes like, I'm guessing what I'm pulling out, right? And then once you understand GCF, then you have to understand how polynomials work, right? When you divide polynomials, you're really subtracting the exponents. So it really incorporates 1,001 skills, right? Build upon each other in order to do this. So that's why a lot of students struggle. A lot of adults struggle with this. It's because it's so many different skills in one. So don't feel bad. Just keep on practicing. And I'm telling you, it will click. Okay. Get that one teacher that explains it to open up your brain. All right. Okay, so we do have a couple of more of these. And then, of course, we got to get into trinomial factoring, right? That's where it really gets into. So this is called factor by grouping. And then this is, I would say, distributive property factoring, okay? So for number 1, we're looking at each term and we're seeing what they all have in common. They all have an X in common, okay? So I'm going to divide this by X, divide this by X, divide this by X. Well, X divided by X is 1. Plus, can somebody tell me what do we get for this next term? What goes right here? Can you guys put it in the chat for me? XU, X, XY, XY. XY. Ooh, most saying XY. So a lot of people are saying XY. Good. X to the square divided by X. Let's go over here for the people that don't understand why we're saying XY. Okay. If we draw this out, XXY over X, these X's cancel, and then that's why we're only left with an XY. So I hope that clears up for people that are lost on why we're saying XY here. And you could do the same thing here. But if you know your exponential rules, right? That's why we learn exponential rules before we do polynomials. We subtract these exponents and we get x to the second. We have no y's to cancel out, so y to the second. Put your plus sign. And this is our answer. That's all we can do. Thank you, Custom Design, for the roses. Do you always teach algebra? No, I teach, do you always teach algebra because I'm in 8th grade and I want to prepare for algebra next year? No, I teach 6 and up. So I teach geometry. I teach algebra 2. I do GED, ASVAB, HESI, like all kind of different math for people that are trying to get into the job placements. How often do I go live? I've been trying to be more consistent, y'all, but for kids, I can get on when I can get on. But I try to go on live every day or every other day. That's my goal. Thank you so much for the love. Okay, so let's look at this one. So I look at each term and I see what do they all have in common? Well, they all have a P. There's a P here, and a P here. Now I could divide this by P, divide this by P, and divide this by P. Okay. Oh, you about to take your T's? I need this. Oh, I'm wishing you the very best. Good luck. And yes, I do do private tutoring, one-on-one tutoring. Email me at impactmath19@gmail.com. Also, you guys, if you follow me on YouTube, I post all my lives over there. So if you ever can't catch a live and you want to look back and see what I worked on, I post all my lives on my YouTube page at impactmath19 as well. Okay. Okay. Pepe said 3p r squared. Yes. 3p r squared. Beautiful. These cancel out as 1 and we're left with 1p. Plus, these p's cancel out, so we're left with 6r. Plus, can you guys put it in the chat? What do we get here? Oh, I'm sorry, you guys can't see it. There you go. What do we get for the last term? 1, 1, 1, 1. Beautiful, you guys. 1. Okay, we had a question. Wait, why can xy not be added to the xy squared? Ooh, Kay, great question. So Kay said, how come we can't add these? Well, Kay, they are not like terms. And why they are not like terms is because they don't have the same exponent. See, in order for something to be like terms, they have to have the same letter for one and the same exponent. And since these don't have squareds, we can't add them because they're not like terms. Great question. Can you show the first cancel again? Yes. So let's I'm gonna show this first cancel. So if we have 3, I'm gonna write out how many p's do we have? P. Thank you, Chris. Thank you so much, Chris. Over p. Okay. So we have 2 p's and 2 r's over a p. These p's canceled out. So what we have left is 3p. We have 2 r's here, so we write r squared. Greenlee, I hope that helps. Ray, okay. Oh, you're so welcome, Green. Thank you so much for the heart me's and the roses. All right, so now this is where it starts to even get a little bit more challenging, right? What is the GCF for this? What can we pull out of number 3? Good. Somebody said I'm starting to remember this from high school. I love it. AB, 3, 12 AB. Sip said 12 AB, 12. Good, yes. So we have 12. They both have an A and they both have an B. Okay, 12AB, beautiful. So if we divide this by 12AB, 12AB, 48 divided by 12 is 4. A squared divided by A, remember we subtract these, will give us just 1A. This is 2 minus 1 gives us 1B. Minus 12 divided by 12 is 1. A's and B's cancel. And so that's why we just have a 1. And this is our answer. Yes, good, your mom. Yes. Yeah, let's go. Okay, Sarah, you have a question? What's your question, love? I love when you go live. Oh, thank you. Thank you, Shay, for the rose. Why did we pick 12AB? Because we're looking for, and see, that's why this becomes kind of challenging, is because we're looking for the greatest common factor. So we ask ourselves, what times what gives us 48? Well, we can get 48 by doing 4 times 12. And then what times what gives us 12? 1 and 12. Since they both have 12 in common, that's why we pull out the 12. So how come the P in question 3 didn't cancel? Oh, wait, somebody asked, why the P's don't cancel out on the other problem? Oh, they did cancel out. P divided by P canceled here, and that's why we got 1. How come the P's in question 3 didn't cancel? Yeah, so a lot of people, sorry, I just didn't cancel it out, but they do cancel here. P divided by P, that's how we got 1 here. And then P divided by P canceled, and we left us with 1P because we had 2 P's over 1P. I'm doing this in college and I can't remember it from high school. Yes, if you don't use it, you forget it. I'm telling you. Somebody said, can you take 4AB? Can you take 4AB, 12AB minus 3 as an answer? No, we cannot. And let me explain why, okay? Because somebody asked that. That's a great question. Can we take 4AB, 12AB minus 3? Well, see, the problem is when we look at 12 and 3, we still have something in common. So we could still divide by a 3 here and a 3 here. So this is one step, but then you would have to pull out this 3, and then you would have to do 3 times 4AB, and then you would have to do 12 divided by 3 is 4AB minus 1. That's why we can't take this, because it's not factored all the way completely, because you didn't pull out the GCF. You pulled out a smaller number than the greatest common factor. Great question, RB. Oh, somebody said move the notebook. Okay, so remember the GCF? Yeah, thank you. Okay, good. Thank you. You're so welcome. Okay, so now, let's see. Somebody asked, Ava said, for harder problems, how would you further simplify them in general? All right. So Ava, before we jump to trinomial, because this is still on the same question, same type of questions. So Ava said if we have 4B, 8AB squared plus 4B to the cubed plus 6b, right? How would we further simplify this? Well, we could further simplify this. Well, let me ask you guys, what number can I pull out of an 8, a 4, a 6? What number can I pull out of there? Thank you so much for the roses, Christy. Thank you, thank you. So I see 2, 2, 2. Yes, we can pull out a 2. Also, we have a letter that we can pull out because they all have a B. Thank you, Lisa, for the roses. So we can pull out a 2B. So if we pull out a 2B here, 2B here, 2B here, we have to make sure we multiply it by what's on the outside. So we're doing 2B times 4B because this 4B was already out. And then 8 divided by 2 is 4. Okay. We have an A that's left. And then 2 minus 1 is 1B. Plus 4 divided by 2 is 2. We have 3 B's on top and 1. 3 minus 1 gives us B squared. Plus 6 divided by 2 is 3. These B's cancel out. And so once we multiply this is our answer. Multiply this together though. Oh, thank you, AMT. Good. Okay. I'm glad you guys see it. Good. So Lena said 8b squared. Yes, that's what's going to go on the outside. 8b squared. And then you would copy this down. Beautiful, you guys. So how did you get the 2b? Well, we asked ourselves what times what gives us 8. Okay. 2 times 4. What times what gives us 4? 2 times 2. And 6 is 2 times 3. If you look at all the numbers, they all share a 2. So that's why we could pull out a 2. Every variable, every term had a B. And that's why we could pull out a B. So I hope that makes sense. Okay. Why we were able to pull out a 2 out of 8, 4, and 6. They all shared a 2. Okay. All right, so let's go to factoring by trinomials, okay? Now, there's a multiple thousand ways you can learn to factor by trinomials, okay? I'm going to show you a few different ways because I believe there's multiple ways people can learn and not get stuck on one way, okay? So we're going to first do how I first learned it in college. Well, it's solidified in college, right? You learned it in high school, but who remembers high school? So I'm going to tell you the way that my teacher, my college professor that made it stick for me, okay? Okay, so you ask yourself, first you look at your signs. We all have plus, okay? So it's all positive. So that's going to be plus and plus. Then we say, what times what can give us x squared? Well, x times x gives us x squared. Okay. Then we say, what times what gives us 42? Well, 7. Okay, so we could do a whole bunch of things, right? For 42. We could do 1 and 42, 2 and 21, 3 and something. But 6 and 7 gives us 42. Okay. What is 3? 3 times what gives us 42? Let me see. 42 divided by 3 gives us 14. Okay. And I think that's it. 7, 8, 9. That's it. So now we look at which pair of these can add up to 17. 1 and 42 are too far. 2 and 21 are too far. 3 plus 14, if we add those, we get 17. So this is our pair. And we put a 3 here and we put a 14. And this is how we factor trinomials. Mom, your mind's blown? Okay. I hope it's blown in a good way and not a terrible way. Yes. Brought back memories of calculator. OMG, so easy. Wow, this is all new, but really interesting. Thank you. Oh, you're so welcome. Okay, good. Okay, what about the 17x? Well, we got the 17x because we said 3 plus 14 gets us 17. And so this is a great question. So let's talk about this, okay? How do we know we got 17x? I always say, because when you have a multiple choice, right? You really, in all the, like if you have, like, so let me explain what I mean, okay? So we have a multiple choice test, right? Let's say most standardized tests are multiple choice. So if we're looking to, well, I always teach my students, okay, can't do it because they don't have them. But let's say we have this, x plus 3, x plus 14. How you check to see if you got the 17x is you check your outer and you check your inner. So we say 3 times x gives us 3x and 14 times x gets us 14x. Well, we're adding that. So we get 17x's here. So that's why this is true. Oh, sorry, you guys can't see. So you do your inner 3x, you do your outer 14x. And you add those and you get 17x's. That's how you get the middle term to check to see if it works. Oh, thank you. Okay. So let's do a couple of more so you guys can see. Okay. So here we have, let's do some parentheses. Okay. Now, whenever your b is the only negative, this is called the b term, okay? Whenever this middle term is only the b, both signs must be negative, okay? These are factoring rules. Whenever you have plus plus, both signs are going to be plus plus. When only the middle term is negative, both must be negative. Then we go back to asking ourselves, what times what gives us y squared? Well, y times y. Okay. What times what gives us 72? Okay, so I'm going to draw my T, put out 72. 1 times 72. Let's see. 2 times, what's half of 72? 36. 2 and 36. 72 divided by 3. 3 and 24. 4, let's see if 4 goes into it. 72 divided by 4 gives us 4 and 18. I think, do we have it yet? Nope. Gotta keep on going. 5 doesn't. 6. Let's do 6. 72 divided by 6 gives us 6 and 12. 6, 7. Do we see it? 6. 7 doesn't. 8. Oh yeah, 8. 8 and 9, right? 8 and 9. All right, so we got all the factors. So now we go through, because when we add these, we want to see which pair can give us the 17 when we add them. Well, these are too far, too far, too far. 4 plus 18 doesn't. 8 plus 9 does get us 17. So we need a negative 17. That's why both of them have to be negative in order to get a negative 17 when we add them. So we just put an 8 and a 9 here. Good, 8 and 9, yes. And so this is our factor. Now we can always check to see if we got negative 17 by doing our inner and outer, right? So let's go, I'm gonna go over here a little bit so you guys can see it. So the people that are just learning this can actually visualize why. We do our inner, which we get a negative 8y, and we do our outer. Negative 9 times y is negative 9y. Add these and you get negative 17y. So your middle always checks. Oh, because if you multiply those together. Yes, you're multiplying your inner and your outer, and then you're adding them to see if they get you the middle. Okay. All right, let's go to the next. Any questions? Good. Okay, good. Can you do one more with a bigger A? is bigger than 1. Yes, Joe, I have them on the next, I think on the next page. That's where we're going to do ones that have bigger than A. Yes. Starting to make a lot of sense. I'm so glad I came across your live. Oh, thank you. Yes, Calvin, I try to get on every day or every other day for sure. Okay. All right. So we have a plus and a minus. Whenever we have a plus and a minus, we're going to have plus and minus. Okay. Plus and minus. Thank you so much for the rose, Abdul. So we ask ourselves, what times what gives us A squared? Well, A times A. Okay. Oh, thank you, Anna. AMT said 12 and -4. Thank you, Mufasa. So 12 and -4 is what AMT said. Okay, so we have 48. And 12 and 4. Okay, so 12 and 4 can get us an 8. Now we have to decide, since we need a positive 8, which one has to be negative? Well, the smaller number has to be negative, because if we do 12 minus 4, that will get us an 8. So we put the 12 with the positive, and since it's a -4, we put the 4 with the negative. And this is our beautiful answer. Good, you guys. All right. Wonderful. Okay, let's try this one. Whenever you have negative, negative, both answers are going to be still positive, negative, okay? It's only negative. Both things are only negative when only the B term is negative. When you have both negative, it's a positive and a negative, okay? I gave my exam on Tuesday. Thank God I came across your page. Oh, thank you. I hope you did good on it. I gave my exam. So are you a teacher? Because you took your exam on Tuesday. Oh, you have your exam. Okay, on Tuesday. Good. Well, good luck. I wish you the very, very best. Okay, so 7 and 5. Shirley said 7 times 5. Okay, Shirley, let's see. So 7 times 5 is able to get us a 2. But how? Allie said positive 5, -7. Allie, I see you. If we do -7 plus 5, we get a -2 in. So now we know that the 7 has to go with the negative side and the 5 has to go with the positive side. And we always start with what times what gives us this first term. So we put in and in. And this is our beautiful answer. Okay. All right. So Alexa said how? Well, because 7 times 5 gets us the 35. Okay. And now we have to say, well, what can we add to get us a -2? Well, when we add a -7 plus 5, that gets us the -2. So that gets us the -2 in. And so I don't know if I'm explaining it well, but that's how we factor. This one is tricky. Oh, -2 in. Yeah, because the middle term here is -2 in. So that's why the bigger number has to be the negative when you're adding in order to get a negative. Okay, so let's talk about because somebody said that people are guessing in their head. What they're doing is they're listing all the factors of 35. They're saying 1 times 35. 3 doesn't go into it. 5 times 7. And I think that's all the factors of 35. 1 and 35, 5 and 7. I think that's it. So you're looking at which pair. So they're not really guessing. What they're doing is they're listing all the factors and they're saying which factor, when I add them, can give me a -2. Well, the only pair that can get me to a -2 is a 5 and a 7. So when I add these, I have to make this a -7 to get to a -2. So it's not really guessing. They're really going through all the factors of the number. That's why when we did 72 here, you guys, I listed every single factor and I said, which pair can get me this negative 17? Only 8 and 9, when I add those, can give me 17. Does that make sense, you guys? Where do you write the rules? Negative, negative, or positive, negative? So you'll learn this the more you practice these. Whenever you have a negative, negative, it's a positive, negative. A positive, negative, positive, negative. When only the B is a negative, negative, negative. And then, of course, when you have positive, positive, they're all positives. Okay? That's what you pick up when you practice more and more of these. You start to see the pattern of the signs. Okay? All right. So let's go here. Let's do some ones where they don't have the 1, right? This is like, oh, okay. So, I'm going to do this 2 different ways, okay? We're going to do it where we're saying we have positives, okay? So it's a plus and a plus. Then we're going to say what times what gives us this first term. Can I see it in the chat? What times what gives me 5x squared? Can you guys put it in the chat? Yes, I'm so Jess says, remember the triangle method, plus at the top and negative on the bottom. Ali said 5x and x. Good. So we have a 5x and an x because 5 times 1 gets us 5 and x times x gets us x squared. Good. Okay. Can we use the diamond method? Yes, Joe. We can use the diamond method. I'm going to use the diamond method on this one. Okay, Joe? Now we ask ourselves, what times what gives us 24? Okay. What times what gives us 24? Well, 1 times 24, 2 times 12. What else gets us 24? 3 times 8, right? 4 times 6. And I believe that's it. Okay. Now, this is where you have to say, we can't say, oh, what can I add to get to 34? Because we have a 5 here. So this is where you could plug and chug, right? If I put 24 here and I multiply that by 5, that's way too big. So basically what you're looking at is doing, because remember I told you you check your outer and you check your inner, right? So 5 times what number goes here can get me close to this. Well, 5 times 24 is way too big. It's 120. So I know this is not going to work. 5 times 12 is 60. That's way too big of 30. 5 times 8 is 40. That's way too big over 34. But 5 times 6 gets me 30. I'm liking that because this is a 34. So if I put here 4 and 6, right? I know 5x times 6 gets me 30x. And then 4 times x gets me 4x. Well, if I add these, I get the 34x. So this is my beautiful answer. So is it that you can find 5 times 24 and then find out what it goes in? Oh, wait, it says, is it that you could 5 times 24 and then find what goes in it? No, actually, because we know 5 times 24 was 120. That was way too big remember, we're looking for the 34. So 5 times 6 gets me 30. So then I knew the pair of 4 had to go with it. Great, Ace. I love it. Good. Okay, so now let's say you don't get it this way, right? Let's say I don't get it that way. That's fine. We can do the diamond, right? They teach us the diamond method. They say A times C and then B. All right. So this is our A, B, and C. So when we do the diamond method, we're doing A times C. So we're doing 2 times 24. Well, 2, okay, so I'm going to put 2 times 24. 2 times 24 is 48. And then my B is 19. So I asked myself, what times what can give me 48 but add to 19? Well, 48. I think it's 8 and 6 divided by 8. Well, 8 plus 6 gives me not 14. Because if I add 8 plus 6, that gives me 14, which is not 19. So that won't work. Does anybody know the pair? What times what gives us 48 but add to 19? 48. 4 and 12? Nah, 2. 3 and 16. Thank you, Sip and Chill. So 3 and 16. Okay. Or we could have said 16 and 3. It's however you want. But when you do the diamond, you have to understand that these are now your middle terms. Okay. These are now our middle terms. And what we do with these middle terms is these go in place of this 19x. So we drop down our 2x squared. Now I'm looking, okay, I'm just going to write it in order. Plus 3x, okay, plus 16x, because 3x plus 16x gives me that 19x. Then I drop down my 24. Okay. Any questions on this part? So we multiplied our first number and our last number, got 48. And we said what times what gives us 48 but adds to 19. Okay, it's only squared when you multiply. Yes, great question. It's only squared when you multiply variable. Yes, great question. It's only squared when you multiply variables. All right, so, okay. So now you see we have 1, 2, 3, 4. We have 4 terms. Okay, so what in the world were they even teaching me in high school? I don't know. Your mom. I don't know what they were teaching. I couldn't tell you. So now we're going to go back to our factor by grouping. Just like we did in the beginning. That's why we learned factor by grouping before we did this. What do these first 2 terms have in common? What can we pull out of them? Can somebody put it in the chat? What do they have in common? What's the GCF? So what about when we get the GCF starting off? Yep, X, X, X. Good. They both have an X in common. So we can pull out an X. And then remember, we're asking ourselves, X times what gives us 2x squared? Well, 2x. X times what gives us 3x? Well, plus 3. Okay, great. Then we ask ourselves here, what can we pull out of 16 and a 24? What do they have in common? Can everybody take a second to double tap their screen for me? Can we get to 40K likes? I'm double tapping with you guys. 8. Good. 4, 8, 4, 4, 4. Ooh, we're getting 4s. We're getting 8s. Okay, so let's talk about it over here, okay? Let's talk about it. I want everybody to see. If we go with the 4, right? If we divide this by 4, divide this by 4. We're going to get 4. 16 divided by 4 is 4x plus 24 divided by 4 is 6. Does everybody see 4 and 6 still have something in common? So although you can factor by 4, thank you guys. I see those double taps coming in. And thank you, Brandon, for sharing the live. I appreciate it. They still have something in common. So that tells us we did not take out the GCF. It had to be 8. Yes. So if we do plus 8, If we divide this by 8 and divide this by 8, 16 divided by 8 gives us 2x. Right now, I'm loving this because remember, these had to come out the same, right? 24 divided by 8 gives us plus 3. Since these are the same, we know we factored correctly. What do? We take our outers. We take these outers, put them together, x plus 8. And we since these are the same, we drop down 1, 2x plus 3. And this right here is our answer. Now let's talk about it. Did we get the answer by doing the diamond method? Yes. How many more steps did it take us to get there? Way more steps. Then doing the what times what gets us and what times what gets us. And then checking our middle. So it's all on how your brain works, right? There's no one way is better than the other. It's just how can your brain work and comprehend to get you there. But you guys, I do have to get off. I do need to get ready for my tutoring session. That's going to happen at 11. So have a wonderful, wonderful Sunday. And then hopefully I am planning on jumping back on because I need to get through this ASVAB mathematical knowledge test later for my YouTube page. So I need to post that today. So hopefully I'll catch you guys later. If not, have a wonderful Sunday and be blessed. Bye, you guys.